Okay, so we just got off talking about proportional relationships. And so we know that a proportional relationship can be written in the form y equals mx. And in that relationship, we know that m referred to our slope. And a proportional relationship looked like this. I think one of the examples that we used was somebody was saving for something to purchase, and if X was the number of weeks that they had been saving for, and Y was the amount of money that they had. If they hadn't started saving yet, they didn't have any money. At the end of the first week, they had saved $10. So let's say they decided to save $10 a week, and as every week went up by 1, the amount of money that they saved went up by 10, and that's an example of a proportional relationship because y values are equal to 10 times the x, okay? So we're going to use the same concept and just kind of build off of that. And so new this week is going to be, okay, what if I still want to save $10 a week, but what if when I started saving, I didn't have nothing? What if I started off with $25 in my bank account already? And then in addition, I want to save $10 per week starting there. So this is a really, really interesting, very, very important concept. So what first thing I want to do is take a look at how that would affect our table. So if our table of values, and we go back to this was the number of weeks that we had been saving for, and y is the total amount of money we have, that would change things because for the last week, we've been talking about 0, 0, constant, the constant of proportionality is this number, but I'm already starting out with some money in my bank account, which means for the first time, it's not 0, 0. We're going to see something that's 0.25 because on week 0, before he even started saving, he's got some money. What that's going to do to the amount that he's saving at the end of each week. Now, it's still going to save $10 per week. So that's going to change that to 35. And at the end of his second week of saving, he will have 45. And so we have a new table, and this is a new concept that's super important for us to take a look at. This starting out, and this is still increasing by 10, just so you know, for every week that he goes by. The only difference is that we have to take a look at what the effect of having this not be 0, 0 is. And so we saw how it changed our graph from a proportional relationship. Our table. Let's take a look at how it would change our graph. And so remember, if this is the amount of money that we are saving in total, and this is the number of weeks that we are saving for, then normally we had a point that started, let's do this one. Let's graph y equals 10x. He didn't have any money on week 1, but he's still saving 10 per week. Okay, so let's say that's 10. Let's say that's 1. Now enter in this plus 25, and if I start to plot these points, I am going to actually start my savings. If this is 20 and this is 30, I'm actually going to start right here. And I'm still going to save $10 each week. So this is going to actually be right parallel to that, because if this is me saving $10 each week without any money to start, this is me saving $10 each week. Oh, and by the way, I had $25 to start. Okay, and so we are going to start to take a look at this, how this changes our idea of what a proportional relationship is. Number one, it's not going through the origin anymore. So basically, it's almost like it just took that proportional relationship right here and it shifted it up. It didn't change the tilt or anything, the steepness of it. So what we are looking at now is a shifting of our proportional relationships up. And so you can probably anticipate what that looks like in terms of an equation. I'm still saving $10 each week, except I'm starting with 25. And so let's take a look at how that compares to this relationship that we looked at before. This plus 25 right here did not exist before. and now it does. And that's just another way you know that this isn't proportional. Because remember, to be proportional, it has to be in the form y equals mx. There can't be anything after that. So this is us kind of discovering a little bit about what a non-proportional relationship looks like. Another thing to just kind of show you the difference here is that in a proportional relationship table, when we looked at the one coefficient for x, not coefficient, when we looked at the one coordinate for x, the slope was whatever was with the one. What's with the one here? 35. Does that mean that I'm saving $35 each week? No, that 35 means nothing. It just means that's how much money I have after week 1. But that is taking into account $25 that I already had. We know the slope is 10, but it's not paired with the 1 in this case because it's no longer a proportional relationship. So everything we've learned about proportional relationships, we kind of have to set aside for a little bit because the introduction of this whole new, I had $25 to begin with, really throws a wrench in things. And that's what we want to kind of take a look at a little bit more today. So let's take a look at our next example. And that example, let's say everybody knows Xbox Live, right? So let's say you want to purchase an Xbox Live account, and I think the last one we did was like $60. That just takes care of the whole year. I don't have to pay each month. So to just be able to join Xbox Live and participate and play games with my friends online, I have to pay this before I can even start to play and download some of the games, right? And so this is going to be the value that I start at. I've already paid $60 and I haven't even played one game yet against my friend. And I know this isn't true for a lot of these games, but let's just say from $60, I want to download some games. And it's going to cost me $20 for each game that I want to download and play. Okay? And so if I were to totally not have to join Xbox Live, let's cover that up, it would be $20 each game. So you would say y equals 20x. That's what we did all last week. And that would be a piece of cake, right? That would be my proportional relationship. I would say, if I don't buy any games, I don't have to pay anything. And here's my $20 per game, right? However, we are now introducing this concept of a starting value. And we're going to give that a name in a minute. So the starting value for this one is 60. So what I'm going to do with that 60 is say, okay, I'm still going to pay $20 each game. So that's not going to change. I'm just going to add $60 onto that, which is going to give me a table of values. I'll do a vertical one this time. If y is my total cost and x is the number of games that I download, then I'm looking at 0 games. I haven't even logged on to play against my friends yet. I have still forked out $60. That's the startup fee. That's what I have to pay just to be able to log on and play against them. And so after I download that first game, I will have that $60 that I pay one time. I only pay that $60 one time. It's the 20 that I pay multiple times, depending on how many games I buy. So after 2 games, my total cost will have come to $100. 60 of it will have been my Xbox Live membership, and the extra 40 will have been from the 2 games. And how does this affect how we graph this? Well, if this was 0, 0, and this was 10, 20, 30, 40, 50, 60, I'm starting way up here. I'm still paying $10 or $20 per game. And so again, here is my y equals 20x. This was no Xbox Live. This is my proportional relationship of y equals 20x shifted up 60. And that's really what a beginning value means, okay? Let's take a look at this example then. Sometimes it can go backwards. Meaning, let's say you get bunches of money for Christmas, and let's say you have $500 that somebody gives you for Christmas. Okay, this is the gift that you got, and you decide that you're going to budget this money. You're not going to blow it all like you did last year. You're going to let yourself spend $25 each week. Okay? So you're going to spend $25 a week, no more, no less, and that is what you're going to stick to. So if I want you to come up with, and right now we're not so worried about the equation as we are about graphing it. We'll come up with the equation in a second. I just want to see if you could come up with the ordered pairs to graph it. This one's a little more unique. So if X is the number of weeks that I am into the new year, let's say January 1st is the very first day, and Y is the number, the amount of money that I have left in my drawer, in my wallet. So it's January 1st. How much money am I starting with? I have $500. That's what I'm gonna give myself in order to purchase the things I want. After week 1, I have allowed myself to spend. I need you to think about what the word spend means. It means I'm taking amounts of money away from this. So after 1 week, I will only have $475 because this amount just decreased by the $25. And if I go into the week 2 of January, it's gonna continue to go down $25. So I'm not really as concerned about the table. I really just want to see if you would be able to take this and get it into a graph. So, but for right now, the only thing we know how to do is use the table to do that. So if this is the amount of money that I have left, and this is the number of weeks into the new year, okay, I know I'm not starting at 0, 0, right? But I do want you to take a look at this next one. I am starting at 0,500. Lots of money to start. And that is all the way up here. All right, so I'm at 0,500. Now, the next ordered pair that I have to plot, you guys, is getting smaller. After 1 week, I only have 475. So this amount is getting lower. So 1 week, and I know there's, it's a small amount. After week 2, I spend another 25. After week 3, I'm down, and it takes me 4 weeks, and I'm already down to 400. I know my things are off here. This is just an estimate. So what's happening is your line that you're plotting for the first time, we're seeing it go down from left to right instead of go up. And if you remember, I don't know, learning target 8 or 9 or whatever it was, we started by talking about there are 4 different types of slopes, right? From left to right, if it goes up, that's positive. And then we learned that from left to right, if it goes down, it's negative. And so what we should see is that we have a starting value of 500, which is evident right here. We can see it. It's not 0, 0 anymore. It's 0,500. And that, so basically we have our y equals. This is going to be a little weird and it's not how we're used to. But you know what? I'm starting with 500. And what was happening to that 500? For every week that went by, that $500 decreased by $25 each week. You can use W for week, or if you're not comfortable with doing that yet, we'll start talking about that a little bit later. You can say that Y is equal to 500 minus 25x. This amount is decreasing by this number of weeks, this much each time, okay? And so let's wrap this up here. I wanted to just kind of show you that we are now taking this equation that we have used to call y equals mx, and we're adding something new to it. So we're taking this y equals mx, and we're adding what we're gonna call a b to it, okay? And so if y equals mx was our proportional relationship, y equals mx plus b is what we call slope, intercept, form, and the b, here's an easy way to help you remember this. The b is gonna stand for our beginning value. And the b is the amount that we are starting with, whereas in a proportional relationship, we did not. So we're gonna go and investigate in our next video a little bit more about what that number there looks like in terms of our graph.